Uh, if I were grading myself first hour, scale of 1 to 10, or let's go on a letter grade scale, I would give my lesson a B, maybe a B plus. I can do better. So I'll try to be a little bit more thorough with you guys. So I'm going to not write a couple things that I did write and write more of what I knew I should have probably written more of. So first off, you might wonder what is an interval? And an interval is simply just a set of numbers that goes from one point to another. And so like in casual English, I'm not going to write them this time. I thought that might have confused them. If I wanted to say all the numbers from 5 to 10, could someone shut the door, please? That's an interval, like the numbers from 5 to 10. I could also say, if I'm thinking of all of the numbers that are bigger than 6, I could say, okay, so you want me to go from 6 to infinity, right? That's called an interval. An interval is just a set of numbers from point A to point B. So don't be intimidated by the word interval. That's all it means. It's a set that goes from here to here. Good, good. So today we're going to look at intervals in 3 different ways. That's what your whole assignment is based on. Just can I write an interval as a number line notation? Can I do it in inequality notation? And can I do it in classic interval notation? And here in about 10 minutes, we'll see how this has gone, and you can rate me like an Uber driver, like give me some stars as to, I think I got this. So ready? Okay, so I'm going to start the lesson with a number line and show you an interval. So let's say I stuck on my number line the number 4, and I put a circle there, and I shaded like this. This is an interval that you're already familiar with. Like way back in maybe October, could have been like early November, you guys took a chapter on inequalities. Do you remember that? Where you have to change the sign and open circles and close circles and all that stuff. Well, when I had you graph your solutions, you were actually graphing intervals, very, very simple intervals. So what you see up here on the board is an interval. And if you had to describe it to someone like a little kid, like if a little kid walked in here and said, I don't know what that means, you could explain to them, oh, that's easy. It just means all the numbers from 4 to forever big, right? Correct? So like 50, 4.1, 66 trillion, like that's what I'm trying to express is the interval of all numbers from 4 to forever to positive infinity. So this is one of the 3 notations that we're going to use today. And this one is just simply called number line notation. I mean, that's probably pretty obvious, right? Now there are two other ways to express an interval. One of them is inequality notation. And I'm going to do this one next because I want to keep this with stuff that you're familiar with for the first couple of minutes. So if I took that graph and I wanted to write it as a math answer as an interval, I could say this. Oh, you mean all the x's that are greater than 4? Correct. That's another way to express a very simple interval. And this one is called inequality notation. The last one is the one that I'm guessing you probably haven't done before, but people surprise me all the time. The last one looks like this, and you're probably not going to believe me. You might think I'm a little crazy, but it looks like this. This one, and I'll talk to you, don't worry, you're going to know all the ins and outs and all the gory little details before we're done here. This one is what all of your upper level teachers will expect you to be able to use fluently. It's called interval notation. And I know it looks like a point. You're used to like seeing parentheses and a comma. That makes you think of a point in the plane. Math is sometimes about context. It's about being able to read something and know, like, what are we talking about? We're obviously talking about intervals here today. So it's not the point right 4 up infinity. It's an interval that goes from 4 to infinity. Got it? You still with me? Kind of, sort of. Now I'm going to change something right now, and I want you to come along for the ride. You ready? This will be hard for you to modify in your notes, but you'll figure it out. You're big kids. You ready? I'm going to go back to the beginning, and I'm going to color in my circle. You remember this? How does that change my inequality notation? What do I have to add? Do you remember that one, Cody? It's now greater than or equal to, right? So I'd have to change my inequality notation. But you might think, well, why are you insulting my intelligence? Well, I wanted to get somewhere with this idea. And it's this. Pay close attention now to how I'm going to change my interval notation. There. That one little nuancy detail right there has a really big impact on how someone reads your interval. Notice I changed my round parenthesis bracket to a squared off bracket. You could infer from that, like you're all smart learners, you could infer from that that, okay, so let me get this straight. If the circle's colored in and that point is included, then I use a square boundary bracket. If it's not included, then I use a round bracket. Yes, sir.
So if it, we're going to say before on the
Correct. And that will lead us to our next example right there. But yes. And one other little thing I want to point out is, and you may not be ready to hear this yet. You might still be, there's always like the first fuzzy few minutes where you're just trying to get your kind of get into the flow of the lesson. But if you're ready to hear this, here it goes. This infinity will always have a round bracket. Why? The because there's no set, that's an interesting way to say that, because there's no set number. Listen, the square bracket implies that the graph reaches you. So when I colored in my circle at 4, the graph now reaches 4, doesn't it? It includes 4. The square bracket says you get there. Can you ever get to infinity? Never. If anyone ever says, yes, you can, they're liars. You can't. Think about the biggest number you've ever thought of in your life. Add another 0. Oh, you just made a bigger one. You're like, oh, that's got to be the biggest. Add 4. You just made another one. Oh, that's got to be the biggest. Double that. God dang it, I keep thinking I found the biggest one. You cannot ever get to infinity. So infinities will always have rounded brackets. Got it? The other ones, the number blockers that we have in our intervals, they're going to be round or square depending on whether they're hollow or solid. And the last thing I want to say before I now just start bombarding you with more examples is this. This square bracket, you're going to be wanting to use this word, is what we call inclusive. The rounded bracket, you can probably figure out, is what we would call exclusive. And that should make logical sense because you're excluding something, meaning like I can't really get to it, so it's excluded. So far, so okay? Okay, let's go again. And I'm going to start you with a graph again, because I feel like having the graph is really good, the visual aid that it provides. So this is called number line notation. So you've now got an interval. You can see it, you can understand it, that it's the interval of all numbers that go forever to the left. And eventually, as we work our way across, the number set stops at -3. Okay, so let's get to our inequality notation first. What is our inequality notation going to say?
X is less than x.
Absolutely, perfection. What is our interval notation going to say?
Square bracket -3.
I haven't said this yet out loud, but I'm going to, by the way, I didn't actually count this. I like to just make things up, but I'd be willing to bet that I had to say this at least 36 times first hour today. Intervals will always go from left to right. That'll be the first time you hear me say it out of about a lot. Intervals are always described from left to right. Always described from left to right. Got it? So when you're thinking about this interval, what's the furthest left-hand point number that it ever reaches? Left. Very good. And because it's on the left, it's negative infinity. You must use the negative sign when your infinity goes to the left. You must describe a leftward interval with your negative infinity first because we're always left to right, correct? And where does the interval end? And will I put a round or a square?
Square bracket.
A square, because it's inclusive. So you got the basics. Are you ready to head into the others? Yeah, far away. I did not go right to left. Let's take a look. Are you talking about this one? 4 to infinity is left to right. 4 is your starting point, but it doesn't, you just have to always trudge left to right. 4 positive infinity is left to right. Negative infinity to -3 is left to right. It'll always be left to right. I'll make some mistakes, but going right to left won't be one of them. I make little rinky dink bonehead mistakes because I'm getting old or something, but I won't right to left you. All right, let's do another one. This one might be a little bit tricky. We'll see. You're going to have to change your, step up your game here a little bit for this one. How many infinities are we going to have on this one? None. Absolutely none. This does not involve the concept of heading towards infinity. This is a double bounded interval. This one has a goalpost at -4. It has another goalpost at 10, and it is contained. So there will be no mention of the word infinity here. Now, I'm going to write something up here that when you don't have to take Algebra 2 for the record, but in a couple of years, you'll have the option as 11th graders to take Algebra 2. If that's a class that you decide to take, you're going to hear me say this word, and you're going to say this word a lot. It's not a real math word. I just decided years ago that this is a pretty great name for these. This is what I call a squisher. It feels real sensible to me because do you see how all the numbers in the interval are being squished in between two ends? So a squisher like this has a really characteristic look. And the way you write a squisher in inequality notation looks like this. -4 is less than x is less than or equal to 10. Look at that thing. Isn't that beautiful? That's your inequality notation when you have both a starting and a stopping point on your interval. Notice the Pac-Mans are both waka-wakaing to the right-hand side. You'll never have dueling Pac-Mans, like they're never going to waka-waka towards each other, and they're never going to waka-waka away from each other. They're both going to go like this, right? Left to right. So you've got left boundary is less than x is less than big boundary. And all you got to worry about is, do I put the little equal sign? What's our interval notation going to be for this one? I like that you said open. I'm okay with that. Okay. I like that. Good job, Twilight. I have -4, comma, 10, and we have round on the left and square on the right. Anyone who knows what they're talking about would read that and say, oh, that's an interval from -4 to 10. -4 is excluded, 10 is included. So far, so good? All right, finally, we have to put it all together now with union sets. And so let's take a look at a union set. How many intervals do you see? 2, right? I don't mean to insult your intelligence when I ask you questions like that, but it's important that you identify that that's 2 separated intervals. However, to express this as an interval, we have to use a symbol called the union, and I'll show you what it looks like. So let's begin with our inequality notation. Let me color code this because I'm all about the color coding. Could you describe an inequality notation, just the red interval for me? What would it say? Inequality notation. X is x is less than -2. Very good. Could you describe for me using inequality notation the purple interval, please? X is,
Greater.
all you have to do to unite these two intervals into one when using this particular notation is just write the word or. That's saying I could be on the left side or I could be on the right side. Everybody still with me? That is how you do inequality notation when you have a union of two sets, two intervals. And then finally, let's do our interval notation for this. Could someone describe for me the red using interval notation?
And
Round. I want another round because it does not, the graph does not get to -2, does it? How about the purple one in interval notation? Nope.
Okay.
Yep. And this time, guys, gals, instead of writing the word or when you're doing interval notation, you use this symbol. It looks like a capital U. In math, that's what we call a union. So when you want to do a union of two intervals, you put that capital U symbol. In delta math, we'll have this. I'll show you. I'm going to run through and do some delta maths with you before I cut you loose here. So you now know everything you need to know to do this, but I'm going to reiterate these three key words, and I would advise that you write them down because I had to address this so many times. Intervals are always written, described, expressed from left to right. I cannot stress that enough. Negative infinities will always go on the left. Positive infinities will always go on the right. And I mean always. All right, let's hop into, by let's, I mean just me, just come along for the ride if you'd be so kind. Here we go. So this is what you're going to be doing a bunch of practice on. It's going to give you an interval in one of the three notations, and then your job is to write it in the other two. I would tell you, you should always do the graph if you don't have it. Always, because it's a visual thing. It's going to help you if you can see a graph. So let's take what we have up here, the inequality, and let's write it using a graph. Can you describe this to me? What does this interval do? How does it behave? Just using English, where does it go? From where to where? Where does it go? Yeah, it's squish. From where to where? Yeah, plain English. It goes from 2 to 9. So I'm going to click on 2. I'm going to drag until I get to 9, and I'm going to let go. Do you like those circle boundaries closed, or do you want them open? I like them closed. So let's leave that the way it is. Now, as an interval, how am I going to do this one? So do I want square, square, round, square, round, round? What do you guys think? Square, square, because it's inclusive on both ends of the interval, right? And all I'm going to do is simply put 2 for my left boundary, 9 for my right boundary, and then send it. Go again. How about this one? So it's given me the interval notation. I'm going to do the graph first. What's my first one going to look like? What does describe that? What is that?
That's just what last.
Yeah, it's very similar. Can you just use English and tell me what does that interval look like? Where does it go? From where to where? That is right. It goes from -5 completely left. I like the words you chose for that. So the first thing I'm going to do is I'm going to click on -5 and I'm going to drag completely left, as Parker said. I like that. Do you like the circle the way it is?
Yes.
You should not, because that round parenthesis next to the -5 says, "Oop, don't include that." So just, you know this, you've done this before. Click the circle, it hollows it out. What does the other side look like? The one
7 completely.
7 completely to the right. So you click 7, pull completely to the right. Do you like that circle the way it is? You shouldn't. Good. I always love to get the graph. It helps me so much to see a picture. And now I need the inequality notation. So here it goes. When you do these inequality notations, it's really easy. You actually just write one and then write the other. So like this one that I just circled in red down here, what is that going to say? As an inequality, what would it say? Keep it simple. X is, nope. X is less than, so I want to click the little less than button, -5. And I do not want to use the union symbol when I'm doing inequality notation. I want to actually use the English word or. So you just click on it, it's right over here, boop, boop, just like that. And then describe to me the one that I'm circling in purple. How would you say that one?
X is greater than.
X is greater than. This is what you're practicing today. You're hopping around between graphing notation, interval notation, inequality notation. You guys think you got it? Want to do some more practice? Are you good? Can't tell. You good? All right, let's do it. It's in the old Delta Math. I'm going to leave the recording going, except I'm going to pause it so that when you have questions, I will put them on the recording. Because you're probably going to have some questions.